Today we're going to talk about solving equations using addition and subtraction. We've already been doing this a little bit in the mental standpoint, but I want you to think about something. Equations are like a scale, and this scale must stay balanced. And so you initially have an equation where one side equals the other side. And so if we're thinking about this scale, I want you to think of that equal sign as being in the middle. Well, when we talk about an equation, that equal sign means equal on both sides. So for example, if I have something like these bars, and I'm going to say these bars are the x's, and these yellow ones are going to be ones. If I say x equals 5, here's what my scale looks like. My scale has an x on one side and 5 of these little yellow ones on the other side. And the scale stays balanced. You see what I'm doing here? And so x equals 5. That equal sign in the middle keeps us balanced. So if x equals 5 and there's 5 on one side, the scale is balanced. And so I want you to keep that in mind as we go through these equations. And what we're going to do is we're going to start to look at things like this. What if I have something where it's not x that equals 5, but it's like x plus 3 equals 5. Well, then I'm going to have x over here, but I'm also going to have 3 of these yellow ones. And notice, I've got that green x and 3 little yellow ones that are equal to 5 of the yellow ones. Well, if I want to find out what x equals, how many pieces is x worth? I can see already, what do I need to get rid of on this side in order to have just the x? I want to know what just the x equals. Well, if I take one from this side, I have to take one from this side to keep them balanced. Like if I had a scale and I had 100 pounds of gold over here and 100 pounds of gold over here, if I took 1 pound of gold, wouldn't that scale go like this? So I'd have to take one from this side to keep them balanced. So every time I take one away from each side, I'm keeping the scale balanced. Well, if I continue to take away one from each side, notice what happens. I took one from one side, one from the other, one from one side, one from the other, one from one side, one from the other. And I end up with x equals 2. Because doesn't 2 satisfy this equation? So x equals 2. That's a simple example. Well, what did I do to get there? To get there, I had x plus 3 equals 5. Well, I wanted to take 3 of those yellow ones from each side, so I took away 3 on this side, and I also took away 3 on this side. So I found out that x equals 2. That's what I normally do in my brain. Well, when we start to talk about these equations, we're going to be doing the same thing. And a couple of definitions that we start out with are equivalent equations, are equations that have the same solutions. So like x plus 3 equals 5, so x must be equal to 2. And I could say x plus 5 equals 7, and in that case x is also equal to 2. So these equations are equivalent because x is the same in both of them. You're also going to talk about inverse operations, operations that undo one another. Like adding 5 and subtracting 5 are undoing one another. So subtracting 10 and then adding 10, well, you get back to 0. They undo one another. That's a couple of definitions for us. And so when we start to subtract and add and do all these things, we're going to talk about these properties. The subtraction property of equality. The subtraction property of equality says if we subtract something from one side and the other side, it's equal. So let's look at this example right here. X plus 5 equals 7. The subtraction property of equality says I can subtract something from both sides. I can subtract the same number from both sides and have and have an equivalent expression. So I can subtract 5 from both sides and keep the scale balanced. Notice, x plus 5 equals 7. You're thinking in your head, obviously x equals 2. But this is the algebra part where we go through and we take apart these equations. You must do the same thing to both sides. If you do it to one, you have to do it to the other. So that was a simple example. Let's look at one. Let's try one. Solve using the subtraction property, show all work, do not use a calculator. And so in this case, let's solve this together. X plus 8 equals negative 15. I want to get x by itself. That's my goal. Get x by itself. And in order to get x by itself, I need to get rid of this 8 part. Okay? And what I'm going to say is, I'm going to subtract 8 from both sides. And here's what I'm going to call that. I'm going to call that a zero pair. A zero pair is two numbers that add to 0. So 8 and negative 8 make 0. So I'm going to put a big 0 around these. So that's 0 pairs. So what I'm left with on this side is only x equals, and now I have negative 15 minus 8, so that would be negative 15 minus 8, which is the same as negative 15 plus a negative 8. So that's 23, and I keep the same sign. So x is equal to negative 23. So I did 0 pairs, I regrouped on the other side, and we came up with our answer. A way to check would be to plug it back in. Is negative 23 plus 8 equal to negative 15? So I could say that would be 23 minus 8 would be 15. Keep the sign of the larger absolute value, so negative 23 and 8. 23 is obviously larger, so I keep the negative. All of this is stuff that we've done before. Next example. X plus 9 equals 20. So my first step is to make 0 pairs. Because my goal is x by itself. 0 pairs. Well, I need to get a 0 pair with whatever is with 9. So I'm going to subtract 9 from both sides. Because remember, you must do the same thing to both sides. You must do the same thing to both sides. So my 0 pairs, I'm doing it to both sides. Big fat 0 here. Gone. X is left equals 11. I can plug it back in. Is 11 plus 9 equal to 20? Yes. So x is equal to 11. Goal is to get x by itself. We're using 0 pairs right now. Next one. Try this one on your own. After the pause, I'm going to go through it so you can see it. A little bit different here, we switched it around, but remember, my goal is to get the variable by itself. If I want y by itself, what is with y? Well, the 3 is with the y, so I'm going to do a 0 pair. And I need to get rid of whatever it is that's with y. Well, this is a positive 3, so to get rid of it, I need to subtract 3. But, must do the same thing to both sides. You must do the same thing to both sides. You must do the same thing to both sides. Because if I don't do the same thing to both sides, that scale gets tipped. So if I subtract 3 from one side, I have to subtract 3 from the other. This is a 0 pair right here. Boom. Goes away. I'm left with y equals, and then I have negative 10 plus a negative 3 equals negative 13. So y is negative 13. Is negative 10 equal to is negative 10 equal to 3 plus negative 13? Yes, it is. So my check is good. Try this one on your own. You're all on your own on this one. All right, so pause it and try this one. The next thing we talk about is the addition property of equality. Much like the subtraction property of equality, it says we can do the same thing to both sides and keep the scale balanced. If you have 100 pounds of gold on this side and 100 pounds of gold on this side, if I add 5 pounds to one side, I can add 5 pounds to the other side and keep my scale balanced. Remember, you must do the same thing to both sides. You must do the same thing to both sides. Must do the same thing to both sides. So if I add 2 to one side, I'm going to add 2 to the other side. This is another way to make 0 pairs. And so in this case, all of these problems are going to involve subtraction, and I'm going to make a 0 pair. My goal, C by itself. And so what is with C? It's this negative 4.5. You'll notice, when we're doing 0 pairs, we are oftentimes doing the opposite of what's being done. We are doing the opposite because I want to make 0. And so in this case, I need to add 4.5 to make my 0. Well, I must do the same thing to both sides. I must do the same thing to both sides. So if I add 4.5 to one side, I need to add 4.5 to the other side. I'm left with C equals 17.5. I can put it back in to check. Is 17.5 minus 4.5 equal to 13? Yes, it is. That's my check. So my 0 pairs, I'm matching up with whatever's being done to C, or X, or Y, and making that 0. Let's try another one. M minus 14 equals negative 15. Goal, M by itself. What is being done to M? I'm subtracting 14. So to make my 0 pair, I need to add 14 because that's going to be 0 there. You see what I'm doing? I'm saying plus 14 because I have a minus 14. I want them together to make 0. So M equals, I must do the same thing to both sides. I must do the same thing to both sides. Must do the same thing to both sides. So if I added 14 to this side, I have to add 14 to this side. Negative 15 plus 14. Different signs, so I subtract the easy way and keep the sign of the larger absolute value. Well, which one has the larger absolute value? It's obviously the negative 15, so I keep the negative, and M equals negative 1. Alrighty? Try this one on your own. I flip-flopped it on you. Your goal is to get Z by itself. So we're going to go that way, see what you can do, and we'll see you in class. Thanks for watching. We'll see you next time.